Given an n by n grid of characters board and a string word, return true if the word exists in the grid. The word can be constructed from letters sequentially adjacent cells, where adjacent cells are horizontally and vertically neighboring. The same letter cell may not be used more than once. All right, so when I see a problem like this, I'm thinking it's definitely backtracking because we have to go down and explore multiple paths because we're not going to know if we can spell this word without getting to the end of the word. What if we want to spell the word yes, Y-E-S, and we see Y-E and we follow that path, but the next letter is D, Y-E-D. Now you have to backtrack back up and try another path. Does that make sense on how this problem may be conceptually like a backtracking problem? Just to determine that from the problem statement and looking at the test cases? What is the first thing? Does anybody have an idea what's the first thing we should do to solve a problem like this? There's no dumb ideas either. Like any idea is good, just to get the gears turning.
Wouldn't we usually like check the example that's given to us and then see how like we can input that? Because that's what I would do, like after reading the
All right,
question.
all right, perfect. All right, so let's look at this first example here. So the word is A, B, C, C, E, D, and we have this grid here. How can we formulate this answer? How can we know that that word is in the grid?
We can basically like go through each one of them. And if it's like backtracking, um, wouldn't we like do like the down and right? But then again, A, B, yeah. But the only thing is like if we like were to like try to use like the backtracking that like from the previous slides, the only thing is like we wouldn't be able to go to D. So I'm trying to like
We go to B from where A?
it's like because remember like when I was showing the first slide, it'd be like
Mm-hmm.
down or right. I don't know if it's like specifically like restricted to those specific movements, but it does make sense to like go to like A, B, C, C, and E. However, D is the only concern for me right now. Like if we're like try to like go through it using backtracking.
All right, that does make sense. But in the problem statement, it says you can go horizontally or vertically. So I would assume we could go to the left or up
All right.
because horizontally just be horizontal vertical, unless it specifically states
Okay.
that. I would stay away from
Okay.
going backwards if that was possible. But definitely, so
Okay.
we need to go. How can we traverse a grid up, down, left, and right? We're gonna need like a directions tuple or like an array or something. So we need directions. direct, and let's call it direct, and it's going to hold a list of values. All right. Do you guys know how to traverse a grid? What up, down, left, and right would be from any cell? And I'm only asking because this is pretty important. If you get this down, solving backtracking problems will be very easy, or at least a lot easier, because you're going to end up having to make these direction arrays very often. So let's say hypothetically we're at.
Like
Oh, what's up? No, can you keep going?
oh, I was gonna say okay, I was gonna say like we could like check the rows and range like the rows, like the numbers within the rows and the columns, like go through the range. So that's what
Yeah.
I'm thinking right now.
Mm-hmm. So let's say we're at A and we want to go to see if the cell to the right is the cell that we should use. If let's say so, if A is 0, 0, what would B be?
Maybe
Zero
like
one.
0, 1. What pattern did we use here? What did we do?
Same row, different column.
Correct. So let's go back here. So let's say we want to go to the left. It would be in the same row. So we're gonna keep it at 0 and add 1 to the column. So that would be going right. Let's say we want to go left. Same idea there. We're gonna go stay at the same row, but instead of going positive to the column, we're gonna go negative. Because if we're at 0, 1 and we want to go to 0, 0, we have to subtract 1 from the column. Hopefully that makes sense. Let me actually close this out. All right, now we're gonna go up and down. So let's say we're at the cell. Let's say 0, 0 again. How would we go down if we want to visit the cell? Let's see here. 1, 0.
be like one. We're trying to visit. If we're trying to visit C, it would be like um, one, and then two. Wait, so 0, 1, 2. Maybe like
Wait, no, we're trying
one,
to
three,
visit
or
S from A, like
oh, from like
this
S.
traversal. Yeah.
Okay, I thought we were trying to go to C.
Wait, no problem.
1, 0.
1, 0. All right. So to
Or
go
S.
down, yeah, to go down, we want to go down one cell. Someone actually put it in the comments. Tangy, uh, Junior Tangy or Jr. Tangy. So that is to go down. Now
It's junior. I think it's -1, 0.
-1, 0 to go down. Why -1?
because we are going down. And
So what row is this? Right here.
It's +1. That's
it's
row
0, right?
Yeah, it's 0.
Yeah.
And which row is this?
That's row 1.
1.
Mm-hmm. So
it's
from 0 to 1, it's
okay,
plus
yeah,
1.
yeah. Sorry. Yeah, it's 1 0. Sorry.
No, it's no problem, man. I've tripped up on that so many times. All right, and the final one would be to go up, and that would be -1 0. All right, so we have our directions. Let me erase this. Perfect. All right, so we have our directions. Now from any cell, we know how to traverse in all 4 directions, which is what the problem statement says we're allowed to do. Next, we're going to have to create a backtracking function because almost all backtracking problems are going to ask you for, you're going to have to make a backtracking function. So we can just call it something like DFS. So define DFS. And the single most important part, well, I'd say it's pretty up there. We have to know what are our parameters of our function. What is the information that would be important for every call to know? And you can get hints from the problem statement. You guys just throw anything out there. There's a couple parameters we're gonna need.
Yeah, what's the question?
Oh, so we're gonna make our backtracking function. What are some of the parameters we may have to put inside the backtracking function? What information would each call need?
Someone in the chat said rows and column.
Rows and columns, beautiful. So we're gonna have let's say row, column. All right, so now our backtracking function knows what cell we're at. Do we need anything else?
Probably list to store element.
Perfect. So let's call that the path, the range. Okay. All right. So let's go over. So the list of store element, I'd say correct because we need a path to know how what words we have so far. And you said the range.
So like for like I heard like the letters, like the range for like rows and columns for the letters. But I think like that already like it's been addressed with the directions though.
Yeah. Let's see. I'm gonna give you guys a quick hint. Let's see. Where? All right. Does this give you guys a clue? The same letter cell may not be used more than once. How do we make sure we don't use the same letter cell more than once?
Using a set.
Perfect. So let's just call that scene. Scene will be our set. I'm debating if we should add one more thing. Sometimes I like to add an I just for index because we may want to know what point in the array we're at. So let's just add that. I is just going to be the index. So that's what letter we're looking for. So hypothetically, let's say we start off at let's see, letter A, and we know that the next letter is B, but we have to tell the function that we're looking for letter B. Does that make sense on why we might need an index? Think about it similarly to the subset problem, how we had the start variable. So it's essentially the same idea there. All right. Next, in all backtracking or recursive algorithms, what do we need first? What's the first thing that is at the top of every recursive algorithm?
We need a base case.
Correct. What's our base case? How do we know we've won or we've gotten to the end? We found the word.
Wouldn't it be like through iterating through each like rows and columns and then seeing like what letters or like what word we're like looking for? And if we basically see it like within a board, we collect it and like add it.
Mm-hmm. So if we see the right letter, we add it.
That's what I'm thinking.
Okay.
Not like the right letters, but like you see how like it has like A, B, and C, like all of like the highlighted words. Basically like if we like throughout all of like the rows and columns, if we essentially see those specific letters, we would like account them and then we would add them to like our like we would like store them or like save them. If that makes sense.
Yeah, I'm following you there. So we'd store them in our path, right? So just like in the subset problem, we had a variable subset, so path. So we could say what could we say? What's a good base case? I don't want to just give out the answer. What do you guys think? There's 2 possible ways to do this. We can either use path or we can use I. Does anybody have any ideas?
Check if we're at the last index.
Correct. I love that. So we could say if I is equal to the length of word, because we're only going to increment I. Yep. If I goes out of index, perfect.
Also check if it's matching the last letter.
Yeah, definitely. But we're actually going to account for that before we go into the backtracking call. We're only going to call our function if it is the correct letter.
Oh, then yeah, it's good.
So we should say return true. But that's definitely the right thinking. I'm gonna call on you when we get to the that part. So return true. All right. Next, what do you guys think we do next? What do we got? We know what our base case is. Let's say we're dropped in a random cell in this grid. What should we do?
We could go through each direction and the direct.
Yep, I love that. So let's say this is how I usually like to do it. Since we're using a 2D tuple, we can say for R C in indirect. So it will unpack these. So every R will be the row and every C will be the column. And what I like to do here is assign new variables. I'm going to say new row, which just in R stands for new row, equals our original row, which we have in our parameters, plus R. And if we, I don't know if I think I erased it, but obviously, let's say we're here at 0, 0, and we want to go to the right. We would add 1 to the column. And as you can see, going right is 0, 1. So we add 0 to the row, which would be 0 plus 0, 0. Add 1 to the column. 1 plus 0 is 1. So this is our new row column, and that would be 0, 1, which would be the B going right. All right. I said plus 1, plus R. And same thing for the columns. We're going to say new column equals col plus C. So now we know this is the possible new cell that we can go to. What do you guys think now? We have a new cell. We're looking at all 4 directions. Is there anything we should check?
It's matching the letter at that I, and then we call the DFS on it.
Mm-hmm. But is it possible it goes out of bounds? What if we're at A and we want to look up? What would happen?
Oh yeah, we have to check for that too.
Yeah, so it's there's a pretty quick way to be able to check if you go out of bounds that I really, really like. I say if, well, first what I have is, since we know the size of our grid, I assign 2 variables called rows and cols, and we're going to make sure we don't go over the rows and cols. And quickly go over that. So we're going to say rows equals the length of our variables called board, B-O-A-R-D, and our cols is going to be the length of the subarray. And just to quickly explain that, as you see, length of board equals the length of the board, and we're going to call that rows. So the length of this is 1, it's like 1, 2, 3. There's 3 rows. And we say the length of cols is going to be the length of the inside subarray. So 1, 2, 3, 4. That's 4 columns. So that's why we have those variables there. And we're going to use that to check if we go out of bounds. So we're going to say if, we're going to say 0 is less than or equal to new row, because we want new row to always be greater than or equal to 0. Because if it's ever a -1, there is no -1 coordinate in our board. We can't use that. And it has to be less than rows. And we do that because, let's go back to our example here. The number of rows we have is 1, 2, 3. Since it's 0 index, we always want to make sure that our potential row is always less than 3. Because if we go by 0 index, this is 0, 1, 2. We want to make sure it's less than 3, which is 2 or below. And our other parameter checks that it's above 0. So that always checks that we're in this range of accepted values. And I'm sure you guys can guess what we're going to do next. The same exact thing for the columns. So we're going to say 0 is less than or equal to new column and less than cols. So that checks if we are going out of bounds. Should we check anything else? Now we know that whatever cell we go to is not going to be out of bounds. What else do we need to know?
Check if it matches the letter at that index.
Perfect. So we're going to say if and board of new row, new column is equal to, and we check that we're given the variable word. So we're going to say word, and we have a pointer to know what letter we're looking for. So we're going to say word of I. That checks that the cell that we're currently looking at is in bounds and has the correct letter that we're looking for. Are we done, or do we need anything else? What do you guys think?
Don't we need to add that somewhere?
What do you mean? When you say add, what do you mean?
Can we add inside a class?
Well, your mic kind of cut off at the end there.
If we have to record whether we've seen it, I think.
That's exactly correct. So we're going to say and, let's see, new row, new column, not in seen, because seen is our set to check in values that we've seen before. So this really long if statement pretty much has the keys to the kingdom. It has all the parameters we need to make sure we're doing the right thing. All right, so now we're going to say, actually, now I'm going to give you an answer. What do we do now? So we know that all the cells are in bounds, and we know that the current cell that we're looking at has the correct word and we haven't seen it before. What do we need to do now?
Did we add them to the path yet?
Correct. So we're going to say path.append board. Let's see here. Board at new row, new column. So let's say we're at A. We know we're looking for B. We see that the cell to the right is B. So we're going to add that to our path. And that's appending it there. Is there anything else we need to do?
Add to scene.
Perfect. So scene.add. And we're going to add new row, new column. All right. So we've chosen an option. Now all we have to do is explore it. How do we explore this path to see if it's going to net the right answer?
We called DFS again.
Perfect. So we're going to say DFS. Our path is going to be our current path. Our row is now going to be new row. Our column is going to be new column. Wait, actually, it's the wrong order.
You mixed yeah.
Yeah. So I'm so used to having the path first. So new row, new column. We're going to have our path here. Our scene is going to be the same. And for I, we do I plus 1. That makes sense. And here's a little trick that I like to use almost all the time in either dynamic programming or backtracking problems. We can use the call to return the right answer, because if this, what are the possible answers that this DFS call could return?
True or false?
True or false. So if it's true, what does that mean?
We should exit.
Yeah, it means we found the word. So we could say, we can use an if statement with this call. We could say if DFS, new row, new column, path, scene, and I plus 1 is true. So, and I just say, this is shorthand for just if it's true. It's the same as writing is true. We should return true, because that means that path has netted us the correct answer. There's no need to explore any further. All right. So this is the backtracking recipe. We added things to our path. We explored it. And what's the next step? Well, there's 3 parts to the recipe. You guys remember? Should have learned in lecture, I believe. All right. This third step is to clean up. So we're going to say path.pop. So if we find a path and it doesn't have the right answer, we're going to undo our work, pop it off. And we have to do the same thing for scene. So we're going to say scene.remove new row, new column. Because if we pop it off, that means we don't want to have our scene set have a cell that we just removed, because we can visit it in a new path. So that's pretty good. Now, the last step. Is there anything we need to add, or is this totally done? What do you guys think?
We return false.
Like this.
Return false. So if none of these things are correct, we're going to just return false. Amazing. Because without that, then this line would not work, because it could just return nothing. And if none would not work, we need to get 2 booleans. At least I believe so. I'm going to have to test that out. All right, so we have our depth first search function. We have our directions. Now, 90% of the work is done. What do we have to do? How do we call it? When should we call this function? Call it immediately? What should we call it with? What would be the parameters that we call this function with? If we just did DFS, what would be our path, our row, column, and path?
So let's pass in the board.
So pass in the row as the length of the board.
Yeah.
So if we passed in, let's say we passed in the row of the length of the board. Let's go here. Do I have? All right. So the length of this board is,
or the first row of the board, rather.
first row of the board. In this case, that is correct. But why did you say the first row of the board?
You want to start at A, right?
You do want to start at A. But what if this was a D here? If this was a D, where would you start then?
Wouldn't it be like at 0, 1, 2, 2, 2, 1? Like no 2, 2, like D, like where D is currently at.
Where D is currently at? Here?
If A, yeah. basically? Because if D takes the position of A, wouldn't it switch out?
Yeah, so let's say we had an A here. We'd start wherever the first letter of the word is. That's always where we want to start.
Yeah. Mm-hmm.
So how do you guys think we do that? Because it could be anywhere. The first letter of the word could be anywhere. It doesn't always have to be in 0, 0.
Wouldn't we even have some cases where it's nowhere and we would return false?
Correct.
So do we
So
need to do a check of some sort?
yes, we have to do a check. We actually have to traverse the whole grid until we find a cell that has the first letter, and then we're going to call our traversal algorithm. Does that make sense?
Okay, and in that case, we can have like an early quit if we don't even find that first letter.
Yeah, let's say we traversed this whole word and there was this whole board and there was no A. We would never even call our DFS function, and we just return false. Someone in chat said index of the first letter. Yes, correct. So to do that, we're going to have to just traverse the whole grid. So we're going to say for row in rows. And as you remember, we have our rows and calls variable here. And that just represents how long the board is. And it could change, so it can't be like a hard-coded variable. So for row and rows, and we can't do that, we have to do range rows. For call in range calls. So this is going to iterate over every cell in the board. And we're going to say if board at row call is equal to word at the 0 index. So that says, that in this case, it would be saying every time that we hit a cell that has the value A, we're going to do something. All right. And I'm sure you guys can guess what we're going to do. So we're going to say DFS. We're going to pass in, see what we have here. What order is this in? So we have row call path scene I. So we're going to pass in the row because that's where we're starting. The call. What do you guys think we should put in for the path?
Wouldn't be like the letters.
An empty list.
An empty list. Why an empty list?
We would have to be updating the path.
Mm-hmm. But let's this function. Okay, I continue.
No, that with each call.
Mm-hmm. So let's say this was empty. We pass in an empty path, and we're looking for B now. When we append B, B is going to be the first letter. We just found the first letter. Yeah. So we're going to pass in board, row, column. A lot of these problems get really, really like tricky, and there's like all these moving parts. So just try to think through it logically whenever you see a problem like this. Don't go too fast at any part, because as you can see here, like I've gotten to points in this many times where you do 90% of the work and you still mess up. So never think you're out of the weeds. All right, so we have the row column, and then we have scene. What is scene? What do you guys? Same kind of idea there. So we're gonna add a set. So this is like the set operator, and we're going to add row column, because if we found the first letter, that means that we've already seen that cell. We don't want to ever go back there again. Set with the first one. Beautiful. That was amazing, Junior. So we have DFS. We have this. Now, we could actually use the same trick that we used right here. We're going to say if this function call returns true, which means we started at this point, we traversed it, and it returned true, that means we found the word. So we can say if DFS row column board with the current letter and scene of this return true, because that means that we found the word. And we should just be able to do at the end of this return false. In that same case that I think Lauren brought up earlier, that if this whole board doesn't have the first letter, it would never hit any of these statements, never run this function, and it would just return false. So as far as I'm seeing, I think we did. Oh, we forgot one thing. Scene and I. And I is just going to start off at 1 because 0 would be the first index, and we just found it here. So we want to start off at the second index. Row column board.
Also in range, you just add whole
Oh, wow. Oh, thank you so much, man. There's a little typo there. All right, so how do you guys feel about this? You think it's gonna work first try? I surely hope so.
Logic, actually, yeah.
Yeah, the LeetCode can be tricky sometimes. Let's see what we got. Invalid syntax. Okay, what happened? Oh, I had one equal sign instead of two equal signs. Try that one more time. Ooh, what happened here? What happened here? Output false, expected true. Output false, expected true. If DFS row column. So we have the row, we have the column. We have our path, which is a. Is that missing a? I don't think that's. Yeah, it's not missing anything. All right, yeah, no problem, no problem. What do we? I feel like it's a simple mistake. I think we traced this pretty well.
Should line 18 be nested, so indented?
Line 18. If yes. Okay, so that. Yep. That was the issue. I believe so. And this function. All right, so we should be good. Let's try that one more time. Really very good find.
Line 20 should be indented
Line.
as well.
Line 20?
28.
28. Indented.
Or
I'm not. Wait, why? Why do you? I'm not sure. Why should it be indented?
oh, never mind.
Let's submit. Let's see what happens. You could be right. I'm not 100% sure. Oh, and there we go. We solved the problem. And it's relatively fast, right in the middle of the pack. How do you guys feel about backtracking or word search? Like, how do you guys feel like walking through a problem like this?
I just feel like you explain well.
Nice.
Very good explaining it.
Oh, thank you. Thank you guys for everyone that contributed and even like stayed here. I really appreciate the contributing. It makes the class move along. You guys are getting it.
Please, could you share the code with the chat?
Screenshot the code. Sure. I could All right, hello. If you made it this far in the video, I really appreciate your time. And if you learned anything new, be sure to drop a sub and like the video. It really means a lot. Peace.